so today we're going to talk about another side of the family of quadrilaterals. We're going to look at the trapezoid side. So yesterday we talked about the side of the parallelogram, where this includes parallelograms, rhombus, rectangles, and squares. And we talked about the different formulas for each one of them, but they're all were based off of base times height. Okay? And then we also talked a little bit about triangles, which again are based off that idea that any parallelogram can be split into two triangles by simply cutting it in half. And that's how we found our formula for area 1 equals 1/2 base times height. So today we're going to do is we're going to look at another side of the family. Your cousins, I guess, when it comes to with trapezoids, because trapezoids are different. Instead of having two sets of parallel lines, it has only one set of parallel lines. These two side angles are not parallel. Now, it could be either one. It could be vertical or horizontal, but this set only has one set of parallel lines, so it changes the formula a little bit. So we know that we could take care of this and kind of work our way through this and go, okay, well, I could take this trapezoid and I could change it a little bit, going, okay, well, what happens if I took this part and cut it right here and transferred it over here? Wouldn't I get myself a rectangle? If I cut it at a 90 degrees right here at that perpendicular to the base and the other parallel side, I could create this. So it is similar to to area equals base times height. But the problem is I've got two different base lengths. I've got this length and this length at two different amounts. But what I can do is I can find the average of those two lengths. So what I'm going to be able to do is go, okay, area is changed a little bit. It still uses height. It still uses the idea of base, but this time it has two different bases. 1/2. Oh, let me clear that up a little bit. So my formula for this is going to look a little different. It's going to find really the average length of the two bases. So it's going to go 1/2 of base 1 plus base 2, and that's got to be in parentheses so we don't break our order of operations, times the height. So what we're really doing is we're adding this up. We're taking the average of these two and dividing it by 2. So other way you could see this is area equals base 1 plus base 2 over 2 times h. So they're two different versions of the same formula. I prefer this one. It just allows me to think all of it in terms of the commutative property, and I don't have to divide one part by 2. I could actually take and divide the height by 2 or multiply it by 1/2 if I wanted to, if this ended up being an odd number. So let's explore how this works, and that's exactly the formula we have right here. And again, just like we talked about base being the two parallel sides and the height being the perpendicular to that. Okay? So if we here's one version of a trapezoid. Okay? So if we take and find the area of this trapezoid, we're going to take and use my formula. Area equals, and we'll go 1/2. Base 1 is 5. And it doesn't matter which one's base 1 and base 2 as long as you have the two parallel sides. 5 plus 12 times 7. That's our height. So we can put this together. We have 1/2 of 17 times 7. Now, I know that it's going to be easier to simply divide 17.5 by 2 to get my answer. So I'm going to go across using order of operations. And I'm going to type this all at one giant step. 1/2 times 17 times 7. It gives me 59.5 inches. Well, yeah, inches squared. So my area in this one is 59 5/10 inches squared. Just like before, we have the same inch idea and how we figure this out. Take a moment and figure out the answer to this one. Pause your video, see what you come up with. All right, so we set this one up as area equals 1/2 of 4 plus 7.6 times 3. And here we're going to go ahead and go one more step. 1/2 of 11.6 times 3. And this would be where I do a real quick answer. And I go, okay, I'm going to split this in half to 5.8 and do 1/2 of, so 5.8 times 3, which gives me an area of 15 4/10 meters squared. All right, let's take a look at another set of problems we could use. Now, let's try the other way around. Let's take a look and think about if we have a missing term this time. Instead of using and having everything and finding the area, what if we already have the area? So we're going to use our same formula, but this time I'm going to fill in all my pieces. I have 108 feet squared equals 1/2. Base 1 is 12. Base 2 is 15. And I don't happen to know the height. So let's put together what I can. 108, 1/2. So this will put these together. That's 27. Half of 27 is 13.5 times h. And then we divide both sides by 13.5. So that gives me an answer of my height being h is equal to 8 in this case, feet. All right, take a moment, pause the video, and figure out the next one. All right, so let's plug this information in. We have this time we have an area of 487 and 5/10 square feet is equal to 1/2 of 25 plus 40 times height. Again, same basic idea. So this time we'll go ahead and go one more step. 487.5 equals, that's 65. Half of 65 is 32.5, 32.5 h, and then divide both by that. You get h is equal to 15 feet. All right, now we found height. Can we find the other one? Can we work our way to figure this out? Well, you could use this in regular forms. You could use this in terms of finding area of more real-life objects like the county of Osceola, Florida. It resembles a trapezoid. It's pretty similar. It's the edge, it's that corner of Florida right by the panhandle. Can you find the approximate area of the county? So take a few moments and figure out the area of both of these, and I'll check the information. We'll type this together in just a moment. So pause your video, and we'll see what we come up with. All right, now that you've had some time, let's say 1/2 of 16 plus 48 times 51. So half of 16 and 48. So 16 plus 48 is 64. Half of 64 is 30. So area equals, I should do that. Yeah, I did that correctly, sorry. 32 times 51. And I find out that this county has an area of roughly 1,632 square miles. It's a pretty good sized county. Do the same thing for the state of Montana. 1/2, area equals 1/2 of 542 miles plus, I keep doing that, 479 miles times 285. So 542 plus 479. So it's 1/2 of 1,021 times 285. So this is a much larger area because it's an entire state. The area of Montana is roughly 145,492.5 or 5/10 square miles. That's a huge area. All right. So it kind of gives you an idea. Now, the other way to look at this is looking at this idea of, can I make this a little different? Yes. What do I have to do when I look at a problem like this? I've got to be sure that one thing to keep in mind with all formulas is that I work in formulas that are in the exact same measurements. You'll notice on this one, 81.6 is in inches and the other two in feet. I either have to convert both of these to inches or convert both this one to feet. And either way works. It doesn't matter how you do it. I like to convert mine to inches. I like to convert mine to feet just because it's a smaller number. So if I would convert this, this would be equal to 6.8 feet. And now I can plug it in 1/2 of 3 4/10 plus 6 8/10 times 3 7/10. So I can type this into my calculator with 3.4 plus 6.8 That gives me 10 and a half, so 1/2 times 10.2, sorry, not a half, times 3.7. Now I'm going to do this part in my head so I can make this faster. That's 5 1/10 times 3 7/10. I find out that this one has a area of 18 87/100 feet squared. Okay, go ahead and take a look at the next one. All right, so I would have converted this to 2 feet, this down to 4 feet, and then I would have worked my problem. 2 plus 4 times 3. So half, so this ends up being half of 6. Half of 6 is 3. 3 times 3, this is actually just being 9 feet squared. All right. Now, let's take a look. Here's your ticket out the door. Think about this. Take a moment and write this down on your notes. How could the definition, the formula for area of a parallelogram, triangles, and rectangles change and connect to this lesson?